Okay, so we're doing exercise 11D from the first year mechanics textbook, and we're looking at question 7. So we're told particle P is moving on the x-axis, and we're given its velocity in terms of time, and it's moving in the direction of x increasing, and then we're told that when t is 0, P is at the origin. So when t is 0, its displacement from the origin is 0. So the first thing we're asked to find is the value of x at the instant when t is greater than 0 and P is at rest. So if P is at rest, that's when the velocity is 0. So let's first of all find out when it is at rest. So I'm told in the question that velocity is 4t minus t squared. So it's at rest when the velocity is 0. So let's take t out as a common factor, and it's at rest when t is 0 or when t is 4. Okay, so if I go back to the question, it didn't say values, it just said value, but that's fine because they're talking about the point when t is greater than 0. So that's the one I'm interested in, and it wants the value of x at that point. So if I'm given velocity, its position or its displacement is going to be the integral of that. So 4t minus t squared. So that integrates to, so t is going to integrate to t squared, and when I divide by 2, the coefficient will be 2. Oh, you can actually see it. T squared is going to integrate to t cubed, and I'm going to divide by 3. And even if you've thought ahead and you've realised already that c is going to be 0, you still need to show that, okay? Because otherwise I think you've just forgotten about it. So when t is 0, P is at the origin. So that is telling me that when t is 0, x is 0. So c is going to be 0. But I just need to show that I haven't just forgotten about that. So my full equation for x is 2t squared minus t cubed over 3. And I'm trying to find the value of x when P is at rest, and I've previously worked out that P is at rest when t is 4. So if I substitute 4 in, that's going to be x at that point. Okay, so that's going to give me 32 minus 3. Okay, so that gives me 32 over 3 meters, or 10.7 meters. Okay, right, now you've got to be quite careful with part B. So if B was an exam question, you'd be able to tell that you were sort of maybe 5 marks, which would tell you there's a little bit to think about here. Okay, because, so I do want to use my previous answer. So I do want to use my integral. But if I just work out the displacement at 5 seconds and the displacement at 0 seconds and subtract them, that's not going to give me the correct answer. So that might be why you're watching this video. Because if you tried that, you weren't a million miles off, but let's have a think about why that doesn't work. Okay, now, I wasn't asked to specifically sketch velocity, but if I do that, it should clear up what the issue is. So velocity is, what was the equation for velocity? Velocity was 4t minus t squared. Okay, and we've already factorised that when we were finding when it was at rest. Okay, so if I were just to sketch that, so it's a negative, so if that's v and that's t, it's a negative t squared, so it's an n-shaped quadratic, and we have already figured that it's stationary at 0 and 4. Right, so what part B is asking me is to find the distance it's travelled in the first 5 seconds. So that does involve integrating, but if you think back to your integration from core maths, integrating between 0 and 4 give me a positive answer. Integrating between 4 and 5, because we've gone below the t-axis, just make sure that doesn't look like it says TV. So because we've gone below the t-axis, that blue area is going to come out as a negative. So it's really just the same as finding areas for your core maths. If you integrate between 0 and 5 in one go, you're not going to get the total shaded area, or the total distance in this case. Okay, because the purple area will be positive, the blue area will be negative, so the blue will cancel out some of the purple. Okay, so you have to be think quite carefully about this, but it is something to watch out for in these questions. Okay, so you know, if it's a function you recognise, like a nice straightforward quadratic, quick sketch can be very, very helpful. Okay, so what I'm going to need to do, so I have already done the integrating. So I have got the integral we've got up here. So don't need to integrate again. It's just how I sub in my limits. So if I sub in limits of 4 and 0, I'm going to get that purple area. So if I sub 4 in, that's going to be 2 times 4. Oh, sorry, I've written a cubed and I meant a squared. So it's going to be 2 times 4 squared minus 4 cubed all over 3, and then if I sub 0 in, that will just equal 0. So that is going to be 32 minus 64 over 3. So that gives me 32 over 3. So in the first 4 seconds, that's how far it travels. Okay, so that's that purple area there. So then if I separately work out its displacement between seconds 4 and 5, and I'm expecting this to come out as a negative, yeah, because I know that it's below the t-axis, so it's going to be a negative area. So that's going to be 2 times 5 squared minus 5 cubed over 3 minus, well, I've already got this, haven't I? But let's write out again, 4 squared minus 4 cubed over 3. So that is going to be 50 minus 125 over 3, and then minus 2 over 3. Okay, and so that gives me minus 7/3, which is good, because that should be giving me a negative answer. Okay, so that's the issue. If you did between 0 and 5 all in one integration, you're actually going to end up with 32 over 3 minus 7 over 3. Okay, and that's not what you want. You want the total distance it's travelled. So what this actually means in real life is it travelled 32 over 3 meters in one direction, and then it travelled 7/3 meters back in the opposite direction. That's what the minus means. But we're not asked about its displacement, so we're not asked about where it actually is after those 5 seconds. We're asked about the distance it's travelled. So total distance is going to be 32, let's try that again, 32 over 3 meters that it travelled in the first 4 seconds, and then plus 7 over 3, because even though that's a negative displacement, I want it as a distance. So that's going to be 39 over 3, which is 13 meters. Okay, let's just double check those answers. So 13 we got, and I think we got 10 and 2/3, didn't we? Yeah, brilliant.